Unit 7, Target 5, Pythagorean theorem, converse and inverse. The point of this target is to be able to do two things. First, we're going to be able to determine if three side lengths form a triangle or don't form a triangle. And second, we'll be able to determine if a triangle is a right triangle, acute triangle, or obtuse triangle. In class, we did an activity with some straws, blue, red, green, and yellow straws. And we had students walk around the room to try to form triangles. So I did that and took pictures for you. And so with 4 different straws and 3 sides at a time, we're able to form 4 different combinations. And you can see in the pictures that the top 2 and the bottom one on the left all form triangles, but the bottom one on the right does not. So I'm going to point out a difference between why the one on the bottom right does not form a triangle and the other ones do. For the first 3 triangles, the longest side out of the 3 straws is on top. So the longest straw in this first picture is yellow, the longest straw in the second picture is yellow, the longest straw in the third picture is green. And if you'll notice, the longest straw on all of those is shorter than the other 2 straws added together. The green straw plus the red straw in the first diagram is bigger than the yellow. In the second diagram, the green straw plus the blue straw is larger than the yellow straw, the third side. And in the third diagram, the blue straw plus the red straw is larger than the third side. And this goes to show that if you add up the 2 smaller sides of a triangle and it's greater than the third side, then that means that you can actually form a triangle. So you can make a triangle on the first 3 pictures. But on the last picture, you can't make a triangle. And so we look at the difference here. The yellow straw, which is the largest side, is longer than the 2 small sides added together. It's the only picture where the longest side, the top straw, is larger than the other 2 straws added together. So you can pause and look at the 3 diagrams and see that difference. Another way of saying that is that the smaller 2 sides, the blue and the red side, those 2 straws, when they add together, they're not larger than the biggest side. And so this creates a gap when we go to make a triangle. And so there's a gap there. So there's no way that the red straw and the blue straw can form a triangle with the yellow. You could move those around, and that's what they did in class, but it just didn't work. So that leads us to the triangle inequality theorem. The triangle inequality theorem states if 3 sides form a triangle, then the sum of the 2 smaller sides is greater than the third side. So for the purposes of our class, C, just like in the Pythagorean theorem, is always going to be the largest side when we're having this type of discussion. So if I take the 2 smaller sides and I add them together, A plus B, those 2 sides have to be greater than the third side. If it doesn't happen, if the 3 segments do not form a triangle, then the sum of the 2 smaller sides is less than the third side, or it could be less than or equal to the third side. Here's some examples. Determine if these 3 segment lengths form a triangle. I'll take the 2 smaller sides, 12 plus 5. 12 plus 5 is 17. 17 is greater than the third side. So number 1, yes, would form a triangle. The 2 smaller sides add up to be more than the third side. For number 2, the 2 smaller sides, 1 plus 2, are equal to the third side. The triangle inequality theorem says that the 2 smaller sides must be greater than. So because this is not greater than, this is not a triangle. And number 3, 10, 15, and 30. 10 plus 15 is 25. 25 is less than 30. So this is also not a triangle. I don't need to square anything like the Pythagorean theorem. I'm just looking at the sides as they are. Go back to the straw example. Number 3, this bottom one, 10 plus 15 equals 30. Or 10 plus 15 is 25, which is less than 30. That's going to look like this bottom one, where the 2 smaller sides, 10 and 15, add up to be 25, which is less than the red side. The red side was 30. Sorry, the one that's in red right here, the yellow straw, I guess. And so when you go to form a triangle, it doesn't work. So that's the first part of target 5. The second part of target 5 was this. Once you know that the segments form a triangle, you could determine if the triangle was acute, obtuse, or right. And so we had students do an activity sheet where they could tell that the triangles were acute or obtuse based on the angle measures and the diagrams themselves, and they discovered this relationship, that when c squared is larger than a squared plus b squared, the triangle was an obtuse triangle. If c squared was less than a squared plus b squared, it was an acute triangle. And if c squared was equal to a squared plus b squared, then we knew it was a right triangle because of the Pythagorean theorem converse. Here's some examples for the rest of target 5. Classify the triangles as right, acute, or obtuse. I'm always going to start with the largest side, which I'm going to call C, and look at that. Square root of 265 squared is 265. The square root and the squared undo each other. If you want more information on that, you can ask myself or another math teacher to explain that really carefully, why that is true. If I look at the other two sides, 11 squared plus 12 squared, 11 is 121, and 12 squared is 144. And if I add up 121 to 144, I'll get exactly 265, which is equal to the 265 from the other side, which makes this triangle a right triangle because c squared was equal to a squared plus b squared. For example 2, I'll take the c value, which is 2 root 13, and square that. We're going to use the property of exponents. We have two numbers being multiplied with an exponent outside, so that becomes 2 squared times square root of 13 squared. 2 squared is 4. Square root of 13 squared is 13. If you take the square root of 13, you'll get a decimal. If you square that decimal, it'll get you back to 13. 4 times 13 is 52. If I look at the other two sides squared, a squared plus b squared is going to be 3 squared plus 6 squared. 3 squared is 9. 6 squared is 36. 9 plus 36 is 45. 52 is greater than 45. So because c squared is greater than a squared plus b squared, I think of that as the angle across from the c is greater than a 90-degree angle. And so that makes it an obtuse triangle. For the third example, I'll do that one really quickly because this video is getting long. The square root of 33 squared is 33. The square, or 4 squared plus square root of 19 squared is going to be 16 plus 19, which is 35. 33 is less than 35, so c squared is less than a squared plus b squared, which makes this an acute triangle. And I think about it as if the c squared value is too small to make a right triangle, then the angle across from it is too small, which makes it an acute triangle.